Hello, pre-calculus student. In this video, we're going to talk about how to graph a general sinusoidal function. We call both sine and cosine sinusoidal functions, but with some adjustment, not just sine x, but something sine, something x, or y equal to a cosine bx. So to experience what the graph would look like, we would actually do some review of track function or of transformation, function transformation. We learned in chapter, I don't know if it's chapter 2 or 3 or even chapter 1, we talk about the fact that when a function's original function, for example, I have an original function of x squared. If I multiply 2x squared multiplied by 2, it would be a vertical stretch, right? So this function is originally like a parabola like this. Now if you multiply by 2, it's like being stretched up like that, right? So this is the same if I have an a multiply in front of sine x or cosine x. It's a vertical stretch. Okay, and then we also talks about what happens if we have, like for example, y equal to square root x is equal to this. But if we do y equal to 2x inside, it's actually a compression. So it's not stretching it horizontally, so it's wider, but actually it's compressed it by 1/2. So the graph seems to be moving higher, faster. So this is compressed by 1/2. So we have the same thing. If we multiply something by b, the graph actually would become like finish the cycle faster. So let's experience this by going into a decimal graphing calculator. So I'm going to graph equal to sine x first. Change the setting so you can see it nicer, and change the step to pi over 2 so you can see pi over 2. Yes. So you can see that this is the basic sine function. 1, yeah, 1, -1. If we zoom in, so you can see this is 2. So if you can see it's 1, and then move it nicer so you will see 1 and then go to 2. That is the sine function. What happens if I multiply it by 2? What do you think? It would be a vertical stretch, so the graph will stretch up. At the 0, it doesn't change, so it's also terminate in 2 pi, right? It's a stretch up. What happens if instead of 2, I do 1/2? It would be, the amplitude would be smaller. So it would just be going up and down, but from the midline, it would be 1/2. Okay, the y value is 0.5 only, whereas this y value is 1, right? So, so multiplying a number outside is very easy to understand. It just affects the amplitude. What about if I multiply something that is inside? So if I say 2x, what would it happen? So it is a horizontal compress in, right? So sine, oh no, not I should say 2x here. Wow. So this is very confusing, but you can see the black one is the 2x. The purple one is original. So if you look at the black sine curve, it still go up and down 1, but it finished the whole cycle in pi, right? So it is really compressed in. So instead of 2 pi, one cycle, it now ends at pi, right? Normally they go up, down, and then at 2 pi, it's one cycle, and then go up, down, another cycle. But for the black one that has 2x, it just go one cycle really fast at pi, and then another cycle. So to multiply it would change the period size in the original one. The one period is to 2 pi, but this one would ends at pi, right? Divided by 2. Your period is being cut into half, so you finish your cycle faster. So in general, that's what we do. So let's look at how to graph it. So I create the graph so you can look at from Desmo. So it's similar to what we had just demonstrated. So, oh, and then we also talk about what I want to, oh, okay, I forgot about that. If A become a negative, okay, so if I of this and then say sine x, but I want to do -1. What happened? What do you think? It will be a reflection, right? So the graph would not go up first and then down, and it would go down first and then up. The same for cosine. So if I off this 2, but change this to cosine, do you remember what cosine would look like? Is a big V, right? 1, go to 0, go to -1, go back to 0, go back to 1. If I do negative, what happened? It would start from, oh no, not sine, with cosine x. It would start from the lowest one, and then this is the inverted V, right? Then go up, go to the highest, and then go down. So that's a negative number is reflection. So let's go back to our notes. We would need to talk about the amplitude because if you stretch up vertically, this would change the amplitude. So the first thing we do when we graph is we calculate a whole bunch of stuff first before we graph. The basic things that we need to calculate is amplitude. Now, if I just do A and B inside, the midline is still in the middle. Okay, so our amplitude will be the absolute value of the A that we have, that is equal to 4. The period now is my B is 1, so it's still 2 pi. There is no B, right? So this -4 would just affect the up and down. The maximum y would be at 4, the minimum y at -4. So I would say 1, 2, 3, 4. I dotted it, I bounded the curve. It would not escape from 4 and -4. But it starts at what? It starts at 0, right? At 0, 0. No, it starts at for the x value, it starts at 0 first. And then because 2 pi, so one ends at 2 pi. This is about one cycle, right? One period. Okay, so we'll say start at 0, ends at 2 pi, this one. This is pi. Is there any reflection? Yes, because -4 is less than 0. So because of reflection, a sine curve will go down. So in the middle, it will go down to the lowest. No, not in the middle. It would be at the quarter point, it go down to the middle. So it'll be like this. And then at the third quarter point, it go to the highest place, like that. And then if I want to do the other 2 pi, so at pi, it always, and then this quarter point, it would go up and go down like that. Okay, so that's 2 cycle. The second one is I want to sketch 1/2 cosine x. Amplitude is this number. That means just what is the highest and lowest point. So that is 1/2. Period. Don't have anything in front of the x inside, so it's still 2 pi. So I can say start at 0, ends at 2 pi. What is the maximum y? Is y and -1/2. Is there a reflection? No. So I would have 2 pi here at the quarter point, because there's no reflection, it goes to the highest, which is 1/2. The lowest is -1/2, because there's no reflection. Quarter point, it would go down and then curve here. Oh, it would go down to the lowest point right in the middle of the cycle. Go back up and then go to 2 pi, which is the highest point. And then to the other cycle would be like this. Okay, so it's not like it's gonna stop, but that's the basic cycle. And usually we graph it. Once we graph it, we will know what it would look like. Okay, so yeah, like that. Okay, so let's sketch cosine and sine curve that has inside. Okay, 2x cosine, cosine 2x. Remember cosine is the V-shaped thing, right? So to remember. And then 2x means the amplitude is, so there's nothing outside, is still 1. But the period now become 2 pi over 2. So if you multiply by 2, you will divide it by 2 because it's finished sooner, being pushed in, right? The maximum y would be 1 and negative 1. Start at 0, but ends at pi. Okay, so it would end sooner, ends at pi, and then the half is pi over 2. The quarter is pi over 4, and the 3/4 is 3 pi over 4. The other 2 pi is just another cycle. So because it's start from 1, so 1 go to this, and then go to the 1, go to the lowest, go back to here, and go here. And if you want to graph another one, you would do this, which is the lowest point. So you would have it go down to the quarter point, go to the lowest, go to the quarter point at 0. At 0 is always those quarter point. Okay, so we have 2 cycles like that. So that is this exactly the same shape as a cosine graph, except it's the period is pi, 2 pi over b, 2 pi over b. I think I have the how to here. So when you graph it, you find the amplitude, which is absolute A. You find the period, which is 2 pi absolute of B. And the cycle complete at 0, 0 and ends at 2 pi over B. If there's A is less than 0, that's reflection. So let's do a sine pi over 5x. So this is B. It affects the period, right? So amplitude is 1 because outside there's nothing. So it will be 2 pi divided by pi over 5. That is the same as 2 pi times 5 over pi. Cancel it. That's equal to 10. So it's very strange. Usually we would have pi and stuff in the x-axis. Now there's none. It's just 10. Okay. And the middle is 5. And this is sine, right? Sine is 2.5 and 7.5. So sine, is there any reflection? No. It's maximum 1, negative 1. So I have a 1 and a negative 1 dot dot dot. It would not go outside of it. It started what? It started 0. It ends at 10. So start at 0, 0, 0, and go to the highest point, go back, go to the lowest point, and go back. So this is one cycle of the sine pi over 5x. You do the same thing, right? So the second cycle would be at 20. You go another cycle like that, okay? So if we have number that multiply outside and inside, for outside it affect horizontal. For outside it affect the y value, where it's higher or lower because it's vertical stretch. For inside it affect the period on how the graph would ends. I'm going to do 2 more, which is combination of a cosine bx. So let's say amplitude would be the absolute value of 3, so it's 3. Reflection, yes. Period is 2 pi over this b. This number b is 2, so over 2. That's equal to pi. The maximum would be the maximum of 3, the amplitude, and negative. It starts at 0, always start from 0 because we don't have any phase shift left and right. It ends at pi's, right? So we would do 1 pi, but 3 and negative 3. 3 and negative 3. So, and then it is a cosine. Remember, a cosine is to be like this and a reflection, right? So this is just cosine x. Cosine reflection would be go to the lowest at this is the midpoint, right? This is the midpoint. The midpoint is when it's go to the lowest, now it's go to the highest. So we go quarter point, go to the highest, go down at quarter point at the x-intercept, and then go this. So this is one cycle, and then you can have the other cycle. Yeah, so this is another at the middle. and cycle. At the quarter point is going, yeah, like that. So this is 2 cycle. Do the same thing on this side. So that's how we do both of them. The outside number affect the amplitude from the midline, and the inside number affect how far one cycle complete. Last one, example 5, -2 sine pi over 2x. Amplitude would be the a value, the absolute value is 2. So it would fluctuate 2, -2. I think this is 2, right? This is 2 and this is -2. Reflection, yes. And you know that sine's reflection, so this is no reflection for sine. Reflection will be down, up. Okay, so it's negative sine x. So the period would be 2 pi, but I have a pi over 2. I divide pi over 2. So that would equal to, let me do the calculation here. That divide means times 2 over pi. That's equal to 4. So 1, 2, 3, 4, that's one period. Okay, this for sine, they ends at the period. They in the quarter, they go to the extended side, but it's between 2 and -2. Oh, okay, it's 2 and -2, including them. What is the maximum y? 2, -2. Start at what? Start at 0, ends at 4, because that's the end of a period. So we get the 3 number, and then because there's reflection, it would go to the go 0 and then go to the lowest point, go to 0 and then go to the highest point. So we dotted them first. And then we'll do the same thing, right? Dot, dot, go 0, go. Yeah, so we graph 2 period, but actually there should be more. Okay. Oh, and then before we go on to the next one, we also want to talk about if someone gives you a graph like this, can you read out the period? I see that it starts from 0 and then I go back to here. This is one complete cycle. So the period is pi. What is the amplitude? Amplitude is the highest, and how much you deviate from the midline is 4. Is this a sine curve or cosine curve? It's a sine curve, right? Because it's like that. Okay, cosine curve is not like that. Sine curve, no reflection. So this. So can I write the equation? So I think it would be 4 sine 2x. Why? Because 2x would have pi period. Okay. So this is one example of how you can look at a graph and write the equations. So in the next video, we'll look at how if I add number inside and outside of the sine and cosine function and how to graph it.